Hey, what's up, guys? Brandon Lee. If you're looking at playing around with Kubernetes in your home lab environment, one of the more complex components of Kubernetes outside of the networking aspect is storage. And it's definitely something that can be intimidating, especially when you're first starting out with Kubernetes. However, I'm going to go through a quick walkthrough of how to enable an NFS share on your NAS device that you may already have in your home lab and use that NFS share as persistent Kubernetes storage. Let's dive right in and see how we can configure this. When you first spin up a Kubernetes cluster, you are content to just simply spin up pods that are stateless. They don't have any persistent data. However, as you actually want to transition from running your home lab services off of a Docker host and let's say move those into a Kubernetes cluster, one of the first hurdles that you will run into is the fact that you need some type of persistent storage for those pods inside your Kubernetes cluster. Now, what does that mean? Well, you want those containers, pods running in the Kubernetes cluster to have a storage location where they can house persistent data. And that's critical. If you lose a host or if you lose a pod, those can be spun back up. However, your data you want to have on a location that is persistent. There are many solutions out there to create persistent storage in a Kubernetes cluster. I want to share with you guys one that I stumbled on just a few days ago that I thought I would share with you guys that I think is a great way to at least get started with persistent storage in a Kubernetes cluster that you may be running in your home lab environment. And it's based on a project called the Kubernetes NFS subdir external provisioner. Now that's a mouthful. However, when it comes down to it, it's basically a project that you can install very easily in a Kubernetes cluster using Helm. Now, if you're not familiar with Helm, that's okay. But just a TLDR on Helm is it is basically like an apt-get command for your Kubernetes cluster. So you can easily just install software like you would on your favorite Linux distribution. Before we look at the NFS provisioner that we want to showcase, there are a few steps that we need to complete just briefly before we install this storage plugin. And the first step in that is that we need to create an NFS shared folder so that when we install the NFS provisioner, we will have that as a target for our Kubernetes cluster. Now, for this walkthrough, I'm going to use a simple and easy example using a Synology NAS device, which you can see on top of my server rack. I'm running a Synology NAS DS1621XS Plus, and I've had that a couple of years now. I've been very happy with it. And setting up NFS in Synology is very easy. So let's look at the steps to do that. As you can see, I'm logged into my Synology NAS device. I'm in the control panel and we're in the shared folder configuration. So all I'm simply going to do is click the create button. We're going to create shared folder and I'm going to call this K8's data test. And as you can see, I've just targeted the single volume that I have configured on this Synology NAS. And we can leave all of these other settings the same. So we can enable a recycle bin, we can restrict access to administrators only. I'm going to click next. And on the enable additional security measure, we're just going to simply click next. We're not going to configure any advanced settings. And finally, we're going to review and simply click next. Now, here, what I'm going to do is I'm going to allow admin read and write access. So simply going to click apply. And now you can see we've got the K8's data test folder. For the purposes of the NFS configuration, I'm going to click the edit button. And as you can see, all the way to the right, we've got an NFS permissions link. So I'm going to click the NFS permissions. And here I'm going to click the create button. On the create an NFS rule, we can restrict the hostname or IP to a single host or we can restrict it to an entire subnet, which is what I'm going to do. On the privilege, we're going to say read and write. Squash, we're going to set this to map all users to admin. And on the security, we're going to leave this configured as sys, and we're going to check the box allow connections from non-privileged ports and allow users to access mounted subfolders. And that's it. I'm going to click the save button and then save one more time. And now we have the directory configured such that we should be able to connect from an NFS client. Now that we have the NFS share in place, it's wise to test connectivity to that NFS share. So let's see how we can quickly and easily test connectivity using NFS and make sure we can connect to our newly created NFS share. What we can do is we can install the NFS client tools on a test workstation or even one of your Kubernetes hosts. As you can see here, I am connected to the first node in my K3S cluster. So what I want to do is I'm going to install the NFS tools, and that can be accomplished using the sudo apt install NFS common, passing in the Y to confirm it. And let's install those tools. Now, one thing that you want to do before we test is we want to create a directory in which we can use to mount the NFS share. So you can create a directory like mount or mount test or whatever you want to do. I've already created this mount directory. As you can see, I'm already CD'd into that mount directory. But if I go back out, we can use the command sudo mount-t for the type of mount. We're using an NFS mount, the address of our Synology NAS, and then also the path to the shared folder. So volume1 / k8 data test, which is the shared directory that we just created a few moments ago. And I'm mounting it to the /mount folder. And as you can see, we didn't get any errors and it returned back to the prompt. So now we can change directory into mount, we can list the contents, and we see the special recycle folder that is created by Synology. So we know we have successfully mounted the Synology NFS share. So there's basically just two steps in installing this NFS provisioner for your Kubernetes cluster. You add the Helm repository, and then you simply install this software in your Kubernetes cluster using Helm. The first command, we're going to actually add the Helm repository, and that is sudo helm repo add NFS subdir external provisioner. And then we have the URL for the actual provisioner. So I'm going to run this command. And so now we've added the repo. Now we want to install the NFS subdir external provisioner. So we've got sudo helm install the NFS subdir external provisioner. And notice the couple of parameters that we're passing. Here, we're actually going to pass in the volume on the Synology NAS. So K8's data test. And then we're going to give it the actual IP address. So 1.149.4. And this should actually install the NFS subdir external provisioner. So here we see we have a successful deployment. We've got the name, namespace default, status deployed. So all looks good. Now that we have the NFS subdir external provisioner installed, let's take a look at our storage classes in our Kubernetes cluster and see what we have defined there after this installation here. So we're going to do a kubectl get sc for get storage classes. Got the NFS client that is now displaying as part of our storage class configuration. But as you can see, the default is set to local path. We want to change this to the NFS client. How do we do that? Well, we alter the storage class configuration so that our new NFS client is the default. So the way that we set that to the default storage class is we patch the NFS client to be the default. So here's the code and command line to do that. NFS client here, and we're changing and patching the storage class so that default class is equal to true. So let's run this. Okay, so the storage class has been patched. Now we see that the local path as well as the NFS client are both set to default. So what I'm going to do is rerun the command However, I'm going to set the local path to not be the default. So let's change this to false. Run that. Let's look at our storage classes. And now we see that our NFS client is the only default storage class. So now we have this configured so that the NFS client will automatically handle provisioning of storage. We can see the volume binding mode is set to immediate. So that means it's going to immediately provision storage for us. Now that we have the NFS provisioner installed, we can test how well this works. And to do that, we're going to spin up a test pod. We're going to use just a simple Nginx example, and we're also going to provision persistent storage in our configuration file. And I'll show you how that's done. What we're going to do, I'm just going to create a pod.yaml file, and I'm going to paste in the configuration that we need. Let me expand this so we can see it a little bit better. So what we're doing is we're creating Nginx-PVC. We are using the NFS client as our storage class. We can see that it's 5 gigs. It's an Nginx pod, and we are creating the persistent volume claim Nginx-PVC. And again, that should be 5 gigs. And we're just doing the normal configuration here, container port, mount path, etc. So I'm going to save and close this. And then we're simply just going to do a kubectl create-f pod.yaml. And as we can see, after we run the kubectl create and pass in the pod.yaml file, we have the persistent volume claim created, and we see that the pod has been created. Now we can do something interesting. We can now look at the persistent volume claim and actually see if our Nginx-PVC has been created. So let's do a kubectl get PVC. And there we go. We've got Nginx-PVC. So we can see that it has been successfully bound, which that is a good sign. We can see the capacity is 5 gigs. Everything looks good there. So I told you guys this was going to be quick and easy. NFS is simple and easy to set up. And one thing I like about it, especially for home lab purposes, is that most are running a Synology NAS, a true NAS device, Unraid, whatever your flavor of NAS operating system and hardware that you have in the home lab. It is commonly found among home labbers to have a NAS that we can easily provision an NFS share. Well guys, I'm Brandon Lee. I hope you've enjoyed this deep dive into NFS storage and persistent storage with Kubernetes. Even though it may seem intimidating, as we have seen with just a few simple steps, you can have persistent storage in your Kubernetes cluster. Well guys, keep on home labbing, stay safe out there, and I'll see you guys on the next video.